Hello friends, welcome to Code Sutra. Even before solving the problem, let me tell you something. That is, if you are not able to arrive at the optimized solution of this problem all by yourself, it is well and good. Because if you don't know this particular pattern, it will be very difficult to come at the intuition of the problem. So I will be talking about the pattern of this problem and why it's a difficult pattern to identify. And at the end of the video, I will also be sharing similar problems related to this pattern. Now let's get into the problem. In this problem we are given n and we are given an array. This n indicates the number of computers and this indicates the batteries with power 3, 3 and 3. Now we have to run these two computers for the maximum amount of time by utilizing these batteries. Now let's run this for the first time. That is, we will run it for time is equal to first minute. What will be the new charges? The new charges will be 2, 2, and since we are not utilizing the last battery, the charge will be remaining at 3. Now let's run it for one more. That is 2. What will the charges become? It will become 1, 1 and 3 will remain. Now for the next minute, if we run this, both will become 0 and we will not be able to run further and we will be reduced to 3. Now can we switch this battery with the first battery? We are just switching here so the time doesn't increase. What will happen is 3, 1 and 1. We have just swapped the batteries and let's now run it again. Now it will become 2, 0 and 1. Now again we will be exchanging the batteries, the last these two batteries. Now if we exchange is 2, 1 and 0. Now can we run it for one more second? Yes. If we run for one more second, it will be 1, 0, 0 and we cannot run any further or we cannot exchange also. So the answer in this case is equal to t is equal to 4. Our answer will be equal to 4 in this case. But if we run straight forward, our answer will be just 3. Why? Because just by exchanging one battery will not be able to run the other computer, right? So now what is the approach? The approach is we have to take many examples just to come up with the approach. Let's take this first example where there are 3 computers and these are the available batteries. If you look at this, what is the time we can run? The answer in this case will just be equal to 1. Why? Because this acts as the bottleneck for the problem. That is, this charge gets over and we are just left with 2 batteries, right? So we cannot do anything. So in this case, our answer will be 1. Now let's take this example where we have 6 batteries, but all we have to do is run just 3 computers. Now let's identify what we can do. First, we have 3 computers. Let's put battery 1, 2 and 3 here. Okay. Now after the first time, it will become t is equal to 0, 1 and 2. Now can we utilize the first extra battery to charge this? Alright, let's swap. Now it will become 4, 1 and 2. Now after we have run for one more minute, it will become 3, 0 and 1. Right. Now we will be putting the fifth battery. It will become 3, 5 and 1. If we run for one more minute, it will become 2, 4 and 0, which will be replacing by 6. Now if you look here, we just can run for 2 more minutes. Why? This battery will get exhausted. So this is not the optimized way of doing this. Now that is, we picked up the first 3 batteries and we tried to exchange with the bigger values of the battery, right? So that is not the optimized way where we can get at the solution. So what is that we can do? First thing we can do is utilize the bigger batteries itself. That is, we will be utilizing 4, 5 and 6. First thing is we have to sort this array. Why we are sorting this array? Since the lower charges will get exhausted faster and we are replacing this with huge higher batteries, we will not be utilizing it in the most optimal way. For example, we replace this 1 with 4, but did that 4 go to 0? No, right? Why? Because the other battery was exhausted even before that. So what we will be doing is we will be utilizing the higher batteries 4, 5 and 6. Now let's run it for 4 minutes. After 4 minutes, this will be 0, this will be 1 and this will be 2. Now we are left with extra batteries, that is 1, 2 and 3. Now we will not use individual. Can we just use it as a pool? And this pool will just give out a sum of 6. We will not care about individual batteries. Now let's just take the pool. Now what we will do from the pool, we will get a charge of 2 here. and we will get a charge of 1 here, and we will get a charge of 3 here from this pool, and now the pool get reduced to 3. Again we get a charge of 2 to this, and it will become 3. So the pool get reduced to 1. Now finally there is 2, and we will add 1 to this, and finally it will become 3. So if you look here, we ran for 4 minutes, and again we can run for 3 minutes. So t is equal to 7, which will be our answer. What we did here was we just sorted the array. Let's find it out in this example. You will be very easily be able to understand this. Now, why is it important to sort and use the bigger batteries? For example, if we use the batteries 3, 5 and 10. 3, 5 and 10. The first battery will be over, right? After 3 minutes, the first battery will be over, and we will become 0 to 10. And if we are using the 10th extra battery and trying to put it here, this will become 10 to 10. And after 2 minutes, this will be over. We won't be able to do anything. So the idea of this problem is to use the bigger batteries first. That is, we'll be using 5, 10 and 10. 5, 10 and 10. 5, 10, 10. So by the time these batteries are running, we can take from this pool. The pool will be of just 3. By the time these batteries are running, we can take from the pool and we can add it to everyone, right? So that is the idea. So what we'll be doing here is we just require to increase this to 8, 10 and 10. So the answer in this case will be 8. But the approach that comes to our mind is we will add all this and just take the average. But the average in this case is 9. But the answer will be 8 because we cannot use every battery to charge every other battery, right? So that is the answer. So what we did here is we sorted the array, then we picked up n max batteries, and we utilized all the other batteries as a pool. Why did we do that? Even before these batteries are run out, all the batteries can be charged, or the minimum battery can be charged. That is why we used for the other n batteries, and all we did was we just swapped or tried to increase the minimum value to the next maximum value, and finally we have the answer. So that is the brute force or the linear approach that we can use. That is, we sorted them, which will be equal to n log n time, and then after we try to increase the pool. Now that is the approach. Now let's come to the not so intuitive approach, that is binary search. This is called the easy difficult approach because once you see this approach, there is no going back. For example, let's take the color red. Until you know that it is color red, you will not be knowing that it is color red. But once you know that it is color red, there is no going back. Binary search with answer space is one such example. Let's look at what is happening in the problem. Let's find out what is the total of all these batteries. The total of all these batteries is 28. Now we have to run 3 computers. So at max, we can run this for 7 minutes, right? We cannot run it for 8 minutes because we have to run all the batteries. So now we have a range. Either we run it for 0 minutes or we will run it for 7 minutes. The first requirement for binary search is that we have a range. Do we have a range now? Yes. After we have a range, the next idea for binary search is if we pick up a number, we should be able to eliminate other half of the search space. Let's say now 0 to 7 is the answer. Let's pick up a random number 4. Will we be able to run 3 computers for 4 minutes? Yes. If we are able to run this, why check 3, 2, 1? Do we have to check this? No. So we can easily eliminate. Now the range is 1, 2, 3. Sorry, this 9 will be the range. 9 will be the range. 4, 5, 6, 7, 8 and 9. We checked for 4 and we thought, yes, we can do with this. So why need to check for 1, 2, 3? Similarly, let's take the range and just for example, let's extend this, and we found out with 7 we are able to do it, or with 9 we are not able to do it. With 9, if we are not able to do it, will we be able to run the computers for 10 minutes or run the computers for 11 minutes? No, right? If we are not able to just do it by 9, will we be able to do it with? No. So we can easily eliminate this. So the idea is we have a range and we can also eliminate the range. So the answer is binary search with answer space. That is, we have a definitive range of answers, and these answers can also be eliminated. How do we do this? How do we eliminate this, or how do we get this yes or no? That is the important problem that we have here. How do we come up with this? Let's for now assume that we have a check function. I will come to the check function, but let's take the values of L, let's take the values of R, let's take the values of mid, and we will check for this. The initial range is 1 because we should be able to run at least the system for 1 minute, and the maximum range is 9. Now let's look at the middle value, that will be equal to left plus right, that is 10, 11 by 2, which will be equal to, the formula that we'll be using is L plus R plus 1 by 2. So 11 by 2, that will be equal to 5. We will see at 5 minutes will we be able to run or not. Yes, we will be able to run. I will come to this 10 function, but at 5 we will be able to run, right? 10, 10, 5. It's an easy thing that we will be able to run. So our new left range will be 5 because we can definitely run for 5 and our R will still remain as 9. Now what will be the new mid? The new mid will be 7 in this case, and also for 7 it will also be true, so let's write it as true. So our new range gets reduced to 7, 9, and the new mid will be 8, and for 8 also the answer is yes. Now the range becomes 8, 9, and again this mid will be 9, 9. For 9 the answer is no, so left and right get reduced to 8, and this will be our answer. Now what about the check function? What about the check function? All we have to do is let's assume we want to do it for t is equal to 8. This will be our input, and what we will do is, see, there are 4 batteries. One is 10, 10, and we have 3, and we have 5. If we are going to run for 8 minutes, what is the amount of energy utilized from this battery? It will be equal to 8. From this battery it will be 8. From this battery all completely 3 will be utilized. From this battery all the 5 will be utilized. Now if we add all this, that is 8 plus 8 plus 3 plus 5, it should come either equal to the energy or more to the energy that we want to run. If we have taken this, what is the amount of energy that we have? We have 24. So we can exactly run the 3 computers for 8 minutes. Now let's take a slightly different approach. Suppose we had 4 here. Can we run this for 8 minutes? No, right? Why? It will be 23. For 3 it will come out to be 7. So we will not be able to run this for 8 minutes. That is, we don't have sufficient energy. Similarly, if we had say 6, we will still be able to run this. Alright. So that is what we are trying to do. In the pseudocode, we have a check function. Let me first come to the check function. What we are doing here is, we are taking the sum of all the batteries, and the sum will not be equal to the sum of the batteries, but the minimum of sum. For example, from the battery having 10, we did not take the entire 10. We just utilized 8, right? So we are either taking the minimum of time or the other value. That is, we will be taking 3 or 8. Whichever is minimum out of these values, we will be picking that. And if this is greater than or equal to the energy required, we will be returning true. If not, we will be returning false. Now this function is very straightforward. We have a range and we are eliminating at each point, and finally we will be returning the answer. Now I understand that this is a difficult problem, but there are very similar problems that you can first try to approach. If you are able to solve this problem step by step, these problems becomes actually quite intuitive and easy, because all these problems are using binary search with answer space. If you are able to solve this, you will be able to solve this problem. Thank you for watching the video. Please do like, share and subscribe.